This video is on extratropical cyclones. I already have a video on the tropical cyclone. In case you want to watch it, I put the link in the description as well as at the end of this video. But in this video, we are going to learn about the extratropical cyclones. It is a type of cyclone which occur in areas between 30° and 60° latitude, both north and south of the equator. In between Tropic of Cancer and Arctic Circle in the northern hemisphere. In the southern hemisphere, it is between Tropic of Capricorn and Antarctic Circle. This region is called the mid-latitudes. That is why extratropical cyclones are sometimes called mid-latitude cyclones, and some part of the cyclone even touches the high latitudes. Generally, in between 25 and 35 degrees north and south latitude, you will find the subtropical region, which is a high pressure belt. And it is also a transition zone from tropics to temperate region. And then in between 50° and 70° north and south latitude, you will find the subpolar low, which is a low pressure belt. And it is a transition zone from the temperate to polar region. In between, the westerly winds are very active in this region, and they flow from the west towards the east. If you're interested to know how these high pressure and low pressure belts are formed at different latitudes, I have a separate video on it. Again, the link will be available in the description and also at the end of this video. Now we'll see how the extratropical cyclones are formed. Try to understand this. Wind circulation is the main reason that creates any kind of cyclone. And depending on temperature, winds propagate between the surface and the upper atmosphere. And always remember, upper atmosphere winds are faster than surface winds because friction slows surface winds. We have already learned that the subtropical region is a high pressure belt, and then the subpolar region is a low pressure zone. We also know that air moves from high pressure areas to low pressure areas. That means there will be air movement from subtropical high to subpolar low at the surface level. Due to Coriolis effect, this wind gets deflected to the right, and that's what leads to the prevailing westerly winds. And then there are winds that occur high in the atmosphere, somewhere between 12 to 15 kilometers above the ground. These are called the subtropical jet stream. They flow from west to east, and it is also one of the strongest winds on earth. The speed of this wind may go up to as much as 500 km per hour. The subtropical jet stream sits between the Hadley and Ferrel cell. And keep in mind, here the wind descends. That's what creates the high pressure zone. There's another jet stream that sits at the subpolar region, in between the Ferrel cell and polar cell. And we know here the air rises. That is why this region is a low pressure zone. That means jet streams form in between cold polar air and warm tropical air of both the hemispheres. Even the jet stream gets deflected by the Coriolis effect, but not much, very little. Jet streams does not maintain a straight flow from west to east. It rather moves like a snake and dips to the south or rises to the north. So far we know that both the wind at the surface and at the upper atmosphere are subjected to deflection due to Coriolis force. And now begins the main explanation for the extratropical cyclone. When air descends at the subtropical region, one part of it heads towards the north and another part towards the equator. And by the way, these are warm air. Now as we go more and more towards the polar region, temperature drops. It gets cold because cold air is also moving from the poles towards the warmer region. Since cold air is dense and heavy, it usually flows nearer to the ground, making the nearby environment also cold. But then the entire polar region is cold, so air is cold everywhere, both at the surface as well as in the upper atmosphere. I'll try and illustrate it in the best possible way. Please try to follow up. So there has to be a boundary where the cold and warm air meets. That boundary is called a front. That boundary is found near the subpolar region. So naturally this becomes the cold front and this becomes the warm front. Since the warm air is light and it expands, on the other hand cold air is dense and heavy, I'll only show the northern hemisphere. Once you understand, the same principle applies to the southern hemisphere too. When warm air approaches the cold air from the south, it gets slightly deflected towards right due to Coriolis effect. This is what becomes the prevailing westerly winds. Similarly, when cold air from North Pole approaches south, it gets slightly deflected to left. As the warm air approaches the cold front, since the cold air is dense and heavy, it pushes the warm air upward. This region is usually called a low pressure region. The rising warm air then comes in contact with the east flowing jet stream, where it splits. One goes east, another goes west. The cold air stream that comes from the pole, they flow towards the southeastern direction in the northern hemisphere due to the Coriolis effect. Cold air is dense, hence it sticks to the Earth's surface under the rising warm air and tries to catch its back. If you look at the flowing pattern of both the cold and warm air, it's in an anti-clockwise circulation. Above the cold air, there's another belt of cold dry air that comes from the poles, which descend from the upper atmosphere and fills up the middle region of the cold surface air and warm rising air. At the top, the warm air climbs over the cold air and series of cumulus clouds appear over the sky and cause rainfall. When the cold air overtakes the warm air completely, it is called an occluded front and the cyclone disappears. This kind of confrontation of a cold front and a warm front can occur both over the land and sea and cover a large area. So this is how extratropical cyclones are formed. I hope you found this video informative. Let me know your thoughts in the comments section. Thanks for watching and I'll see you in the next one.